Hey, everyone. All right. Great to see you all. Good week so far. It's only Tuesday, so we're just starting, but so far so good. All right. Anybody have any questions? Anything you want help understanding? Go ahead, Isaac.
Just a fun random question. What time is it for us?
I'm sorry, say again.
Just a fun icebreaker. What time is it for all of us?
What time is it? Yeah. Type in the chat box what time it is for you. It's noon for Valley. You must be on the West Coast. Jasmine is 3. It's noon for Cam. Noon for Aisha, 3 for Henry. All right, so the noons I think must be West Coast. I thought, did we see an 11? Yeah, it looks like all noon and 3. So we're on both coasts here. Yeah, that is fun, Isaac.
There's one, too.
Oh yeah, there's 1, 2 o'clock. Maisie's 2 o'clock. So you must be in the middle of the country, Central Time. Yeah. All right. That was fun. All right, let's get started. Let me share my screen with you. All right. So we have been talking about rocks and minerals. Of course, remember that minerals are the things that rocks are made of. So I told you guys that if you had a rock that you wanted to share with the group, you could do that. Anybody have one? Anybody have like a real cool rock? No? I left mine over there. Hold on just a second. So you tell me the 3 kinds of rock while I'm grabbing my rock here to show you.
Igneous.
Yep, igneous,
Sedimentary.
sedimentary. What else?
Metamorphic.
Metamorphic. Excellent. So what I have here, anybody have any guess what this is? Maisie, is
Sedimentary.
your hand up? Yeah, Maisie. I couldn't see it with the background behind you. What do you think it is, Maisie?
Sedimentary.
It is not sedimentary. It's actually not even, really. I mean, it is kind of a rock, but this is a piece of petrified wood. Yeah. So what minerals have invaded the wood and hardened it so that it holds up. Yeah. I do have a piece of a sedimentary rock here, though. And because it's not easy to see if I hold it up, I took a picture of one. So there it is right there. This is a piece of sedimentary rock, and you can see it has some fossils in it. Right there's a piece, right there's one. If I turn it over, you can really see them on the backside. There's just pieces of shell that
It's
were
from the
fossilized.
ocean,
Someone gave it to me. I'm not sure where they got it.
but it was
Probably it would
probably
have
in the
been,
ocean.
yeah, because of the shells that are in it, I would guess that it came from near, certainly near a large body of water that would have had shells in it. But yeah, so what is an igneous rock? So what's the difference between the 3 kinds of rocks? Isaac.
Igneous is made from the lava cooling, different types. Metamorphic. Well, I forget how metamorphic is created. It's just rock, I guess, gets created, and then sedimentary is when all the rocks are just like cemented together.
Yeah, it's all the different layers. So the way the rocks are different from one another is by how they're made. So metamorphic is extreme temperature and pressure changes the rock. So what parts of an organism are likely to become fossils in a sedimentary rock like this one? What parts of an organism? Going to be the hard parts, like the shells and bones. Those are likely to become. Hold on just a second. I think yeah, got to get the chat open here. Yeah, you got it. Bones, Ballet, and Drake. Excellent, excellent. So once again, I should go past these and show you mine. If none of you have any rocks or minerals that you want to show anybody, we'll just go on to the next one. And I don't think that, hold on just a second. So we've talked about diamonds and how diamonds are the hardest mineral. Thought you guys might be interested in seeing how diamonds are made. So let's watch this short video to see how diamonds are made.
On a chemical level, a diamond is just a bunch of carbon atoms bonded together in tetrahedrons. This crystal structure is why diamond is the hardest natural mineral, and it beats most man-made ones too. So we know that diamonds are special, but where do they come from in the first place? Diamonds are formed in really extreme conditions, which is why you might find them at the sites of asteroid impacts and even on meteorites in space. But we think most natural diamonds were made millions, if not billions of years ago in the splooshy molten rock deep within the Earth. Over 160 kilometers beneath the Earth's surface, the intense heat and pressure forced carbon atoms into that tetrahedral structure to form diamonds. And then, deep volcanic eruptions blasted them up to the surface at around 40 kilometers per hour. If the diamonds came up much slower than that, the gradually decreasing pressure would let the carbon atoms shift back into other stable forms like graphite. At the surface, everything cooled really quickly to make these igneous rock formations called kimberlites, with diamonds hiding inside. And eventually, we humans came along to mine them. So we know that diamonds are made of squished and superheated carbon atoms, but we're not exactly sure where that carbon came from. Geologists have two main guesses. For one, there could be some kind of carbon-containing sediment deep within the Earth's mantle that never saw the light of day. Or maybe the carbon in diamonds came from organic stuff in subducting tectonic plates, like stuff on the ocean floors, but not coal. That whole all diamonds are just coal under pressure thing is mostly just wrong. See, coal is a form of organic carbon, but it was made mostly out of ancient plants in layers of sedimentary rock closer to the Earth's surface. So it formed way later and way higher up than we think most diamonds did.
All right, so most naturally colored diamonds are created when trace elements, these elements that there aren't a lot of, when they interact with the carbon atoms while the diamond's being created. What do you think gives diamonds color? Sometimes there are diamonds that could be yellow or pink or green or blue. Why? Why do you think a diamond might have a color? Jasmine. You're muted. Well, or your microphone isn't working. No, sorry, it's not working. Maybe try unplugging and plugging back in your microphone. Maisie.
Because they're also by the light and the temperature.
So that's a good guess. Really, Valley has the answer there. There are other minerals in them. There are other elements that are in them, things like nitrogen and sulfur and boron. Those can give diamonds little shades of color. So let's see here. Kaylin, I don't think Kaylin's here today. Oh, that's a shame because Kaylin sent me this joke. Heat, time, and pressure. The three things you need to make a diamond also make a waffle. Heat, time, and pressure. I thought that was cute. So thank you, Kaylin, when you're watching the video. Appreciate the joke. All right. Make sure that you guys understand the difference between weathering and erosion. So weathering is the breaking down of something, the breaking down of rocks or soil. And then erosion is moving it away. So they go together. We have weathering first and then erosion. Weathering breaks the particles down, erosion carries them away. Usually erosion is by wind or water that would carry those tiny particles away to somewhere else. So over long periods of time, the breaking down and disintegration of some of those things can build up, and that actually changes the surface rock. So that is what we call weathering, when the rock itself changes. So look at this. Over time, this was one solid rock a long time ago, but over time it has weathered away until it's got this shape right here. Okay. So weathering is the process of a rock breaking down into smaller pieces. Then the movement of those pieces somewhere else is called erosion. And erosion is usually caused by wind or water or ice as they pick up those particles and carry them away. Now, on a winding river, like something that winds back and forth, usually erosion takes place on the outside. But then particles of rock are dropped as the river moves along. So the buildup of those eroded particles that are moved from their site of origin and left somewhere else, that is what we call sedimentation. So the layers of rock particles are called sediment. So you can see sediment is being deposited right down here in this area. Now, here's how it happens. Sediment is the result of erosion. Sediment, like this right here, is the buildup of those particles that are carried along in the runoff from where they started until they're deposited somewhere else on other surfaces or in bodies of water or in wetlands. All right, so why do we learn about rocks anyway? This guy's going to tell us. What's the whole point of learning about rocks?
We're talking about rocks on this episode, geology. In fact, rock types. Probably sitting there now thinking, why do I need to learn about rock types? Why did I click this video? Well, I'll tell you, rocks are cool. Even if you're not going to be a geologist, it's really important to know what you're looking at. For instance, we do a lot of rock climbing, we do a lot of adventuring. We went last week to Red River Gorge in Kentucky, world famous for its rock climbing. And you talk to any rock climber there, they're going to know what rocks they're looking at.
It's composed of Corbin sandstone, which is a sedimentary rock.
Now besides that, it makes you sound smart in general because you look at a rock face, especially beautiful arches or deep canyons, and people, very commonly ask, how did this form? Where were these rocks before, right? And so if you know a little bit about rocks, you can take a stab at that answer, and even if you're not right, you sound pretty smart doing it.
Well, that's why we learn about rocks, so we can sound smart when somebody asks us about it. We also have to learn about the rock cycle because, like we talked about last week, rocks can change. We've got these three kind of rocks, but they can change. They can break down, they can melt, they can deform into other kinds of rocks. And that whole process of changing is what we call the rock cycle, where one rock changes into a different kind of rock. So there are three different kinds of rock that are in the rock cycle. The first one is igneous. And like Isaac told us at the beginning, igneous rock that is exposed is what is exposed. It's what comes from lava. And igneous rock that's below the surface can break down. It can break down into sediment. Once it's beneath the Earth's surface, it can change into metamorphic. So igneous rock can become sedimentary. It can also become metamorphic. Guess what? It can also become another kind of igneous rock. So then we've got sedimentary rock. How can sedimentary rock change? With temperature and pressure changes, sedimentary can become metamorphic. Or it could get down low enough into the magma, into the mantle, that it melts and becomes igneous rock. It can also become another kind of sedimentary rock if it weathers away and then is eroded. Finally, we have metamorphic. Under certain conditions, like pressure and temperature, metamorphic rock can melt and become magma again. Or it could form a different metamorphic rock. Or it could become sedimentary rock if the particles are weathered and then eroded away. Now, just keep that in mind when you're learning about these. They can all become each other, and they can all actually become themselves again. You can see that here. Rocks can change from one type to another through the rock cycle. Now, igneous rocks form when magma cools and the minerals in it form crystals. So anybody remember what that process is called when the minerals become crystals? Crystals. JR.
Crystallization.
Crystallization, excellent. So the crystallization, when magma cools down below the surface and it rises up, it can form those igneous rocks on the surface. And when they cool and crystallize, then they are, they're a different kind of rock than they were when they were below the surface. So those are what we call physical changes. They're just changes in the physical nature of a rock itself. All right, so igneous rocks. Sometimes we call igneous rocks fire rocks because they're formed underground by that trapped cooled magma. They melt. They're sometimes formed above the ground when those volcanoes shoot the magma, which then we call lava, out onto the surface. So they form in both places. Let's watch him talk about igneous rocks and how they form.
But first, you gotta know rock types.
The igneous.
So I start with the igneous because it's the natural place to start. It's where new rock is formed from molten magma. You see, a couple years ago, Hale and I went to Hawaii. We marched out along the coast of the big island of Hawaii, and we were able to see new rock forming when none existed before.
Glowing behind us, new earth being made.
It's lava forming igneous rock.
When that lava, or magma in some cases, cools, it becomes an igneous rock.
Right there. If you were wondering how rocks were formed, there you go.
Now, when magma cools slowly, it forms really beautiful crystals. The slower it forms, the bigger the crystals, right? So if you were, say, climb the Grand Tetons, which we did last month, you're able to see these giant crystals on the surface of the rock, and it's just awesome.
So I don't know that I'd walk that close to moving lava if it were me. I think that's a little bit dangerous, but it's pretty cool to watch it happen. There are some really cool igneous rock structures around the world. I want you to look at some of these. These are made of igneous rocks. Look at that. That's in Ireland.
Hi guys, I'm here at the Giant's Causeway. The Giant's Causeway was formed around 60 million years ago when molten hot magma erupted from a nearby volcano and quickly cooled down as it reached the ocean, forming these amazing honeycomb pillars. These pillars are made from basalt, which is an igneous rock. Other igneous rocks include granite and pumice.
Hard to believe that's a rock formation. I have a very good friend who just was there last week. She sent pictures walking on that in Ireland. So very cool. Kaylin, I did your joke already at the beginning. So sorry you missed it, but thank you for sending that. We enjoyed it. Yeah, I like that music too, Drake. All right, now metamorphic rock. That forms when rocks that are inside the earth, deep in the earth, are under high pressure and high heat. And they physically change their shape, but there can also be chemical changes inside those rocks when they form. While the minerals that are already present recrystallize, new metamorphic minerals might grow, and that might change the texture of the rock. So metamorphic rocks, they need heat, they need pressure, and that occurs deep inside the earth. So in the process called deformation, metamorphic rock is sometimes twisted and folded. So remember, again, that igneous and sedimentary rock can change. They can change into metamorphic rock, and so can existing metamorphic rocks. They can go through more changes and form new types of metamorphic rocks. So look at these deformations here. This is a good example. This is beautifully just melted and twisted around. It wasn't melted enough to become igneous. Right? It didn't go back to being lava or magma again. It's just deformed by the heat and the pressure to make this beautiful metamorphic rock. So let's watch the video about metamorphic rocks.
Metamorphic rock.
Metamorphic rock. A metamorphic rock is just when you take any of the other rocks and you put them under heat and pressure and you twist them and meld them up. Now here's a rock climbing place in Golden, Colorado that we like to climb. That's metamorphic rock. One of the coolest places. First, to get to it, you got to climb up a tree and zip over on this cable, and then you're climbing up the wall. And one of the things you'll notice is that when you're climbing the whole wall is like twisted and melded up. And that is metamorphic rock because it used to be granite.
So does that look fun to anybody, climbing rocks like that? And you guys adventurous enough that you want to give that a try? Yeah. I'd want a safety net underneath me, I think. All right, and then finally, oh, so go ahead. Oh, I thought somebody was talking. Finally, then we have sedimentary, and that forms from sediment. So compaction and cementation are what forms that sedimentary rock. So we have to have those processes because remember, we've just got this loose sediment and it's just kind of, you know, like think of it as being sandy. It's real loose. Well, we have to have them compacted together as layers and layers and layers of that sediment form they press down. The weight of what's above presses down on what's underneath. And then some kind of compound comes in and acts like a cement that binds all those particles together. Now, those can occur under pressure. So there are often chemical changes to the rock itself, but mostly sedimentary rock forms on the surface of the earth. And mostly you're going to find sedimentary rock up on the surface. Now, they can be carried underground when there's geological processes, when there's like things that happen that cause the ground to crack and open, they can then be found underneath the ground. But here's an example of sedimentation. So look at the different small minerals and how in between those minerals, you have this, this cementation. Something got in there and cemented it. Yeah, I think that's really a beautiful rock. Those are, yeah, dissolved. There's a part, 5 minutes. Yeah, that's cool. That's really cool. All right.
Moving on. Sedimentary rock.
Sedimentary rock.
Sedimentary rock is really cool because every sedimentary rock came very clearly from other rock, and you can almost look at the grains and see it because that rock basically got cemented together from the parts of other rocks. Got cemented together. How cool is that? And maybe the coolest manifestation we've seen is when we went through the Grand Canyon. And not only are you seeing these giant cliffs of exposed sedimentary rock that, you know, are going back millions and millions of years, but you're actually on a river that is actively moving sediment away and depositing it somewhere else.
That's a really good example of how our Earth is constantly remaking itself. It's reshaping the surface features that it has. I live in Pennsylvania, and we have some mountains here, and we've got lots of sedimentary rock. So as you're driving along, you'll see these layers of rock, and some of them are not layers this way. Some of them are this way. It's pretty cool. We'll talk about how that happened when we get to talking about tectonic plates and the movement of the plates under the surface of the Earth. Yes, Henry, the Grand Canyon is continuing to be made deeper and deeper and deeper by the wind and the water that are constantly rushing through it. Yep, it is being destroyed. It's being reshaped. Parts are being destroyed, parts are being built up. So yeah, excellent. All right, so the rock cycle has these 5 processes. It has melting, cooling and crystallization, deformation, weathering and erosion, and compaction and cementation. And this table shows where each of these processes happen. So let's look at melting. What's the result of melting? Magma forms. Magma comes up, it's lava. All right. Where it happens near the mantle or anywhere where you can get hot enough to turn that rock into a semi-molten magma, and then it rises up to the crust. Cooling and crystallization. What do they result in? Igneous rock. And where does that happen? In the crust or on the surface if magma comes all the way up. Deformation forms metamorphic rock. It's being deformed, it's being twisted. And that happens, again, in the crust. It's got to be warm enough. There's got to be enough heat and pressure in order to deform the rock, but not so much that it melts the rock. Then it would be igneous again. What about weathering and erosion? They form sediment. And that, of course, happens up on the surface. That's where sediment is formed. And then compaction and cementation, they form sedimentary rock. That happens on the surface as well. All right, now let's finally watch the last one of these.
The reason for me wanting to tell you about rock types is just to get across the point that rocks change. You see, if you were to look at a rock cycle, you would see that any of the rocks, if they get broken down into little pieces, they can reform into sedimentary rock. If you take any of the rock types and you heat them up until they become molten magma, when they cool, they'll become igneous rock. And then likewise, if you were to take any of those forms and put a lot of heat and pressure on them, they will become metamorphic rock. So almost every rock can become another rock in this giant, cool rock cycle.
Yeah, see, even these little curves here show that sedimentary can become another sedimentary rock. Igneous can become another igneous, and metamorphic can become another metamorphic. All right, so what powers the rock cycle? Where does that energy come from that causes these rocks to change into other kinds of rocks? What do you think? Let's hold our conversation just to answering the questions because I'm going to lose questions here. Anybody have any idea where the energy comes from? Comes from two places. Maisie.
The diamond.
So the diamonds are made by one of these processes, but I want to know what the processes are. Where does the energy come from for these processes? Well, it comes from two places. It comes from the heat inside the earth and from the sun. So heat from the sun, heat inside the earth, that's what powers it. Now down inside the earth, it's hot, right? We know that from when we learned about the layers of the earth. Magma's hot, the mantle is hot, the core is even hotter. And it's hot for two reasons. It's hot because when they think that some large body crashed into the earth and made it molten, and that's what created our moon. And also it made things so hot that the heat's still trapped in there. It's getting out a little at a time, but there's still a lot of heat. Also, there are elements that are breaking down. They are radioactive, and when they decay, they release a lot of heat. So those two processes help us to have both igneous and metamorphic rocks. But then there's also the sun. Most of the energy on Earth comes from the sun. So the sun is what causes wind. The sun is what causes wind to move the water. And the sun is another big part of the energy that powers the rock cycle. So breaking rocks into those small particles, making sediment, takes a lot of energy. So Earth's processes give us that energy that we need to grind down rocks. And the internal processes too give us the energy that we need to change rocks down inside the Earth. So we've got energy from the sun as well as energy from the earth, inside the earth. So at the surface, the processes of the rock cycle usually happen. So that would be the three of those processes. Magma cools on the surface, right? That then becomes igneous rock. Rocks are weathered on the surface when the wind and the water blow past them. And sediment can be compacted and cemented together on the surface. So the things that happen on the surface don't require quite as much energy as the ones that require down underneath in order to happen. So again, what's the source of the energy? Metamorphic rocks are formed by high temperatures inside the earth. Sedimentary rock is formed by the sun, and igneous rock gets its energy from high temperatures inside the earth. Weathering and erosion, again, the sun. Deformation, that's high temperatures inside the earth. So you can see how those two things are what give us the different kind of rocks that we have and the rock cycle. And this is always happening all the time. Rocks are always changing into other kind of rocks all the time. Now, take a look at this picture here. This diagram here is missing two weathering and erosion arrows. All right, so where should they be? Aisha.
Sediment to igneous rock.
From sedimentary to, so let me show you. That one right there. From sedimentary to sediment. Right, that one's missing. From sedimentary to sediment, and from metamorphic to sediment. That's missing. In order for there to be a rock cycle, all the kinds of rock have to be able to turn into all the other kinds of rock. All right. Now, remember what sediment is. Sediment is the little particles. Remember what melting is. That's when the rocks get down low enough into the mantle that they melt, and they can then become magma themselves. And remember what magma is. Magma is what's inside the earth. It's called lava when it comes out. Same exact thing when it comes out. All right. So there's a song that you guys may or may not have heard. It's kind of an old song, like from the 80s. You may or may not have heard it, but these people made a rock cycle video using that song. I thought it might be fun for you to watch.
When cooling takes place, all settle in place. We will rock you. Sing it! We will rock you. Steady changes in heat and pressure, rising from the earth, create metamorphic rocks. Gravity fall in your face, squeezing mineral space. Energy fuels chemical reactions taking place. We will rock you. Sing it!
All right. Anybody heard that song before? Yeah. Yeah, it's around a good bit. It's an oldie but a goodie. Reminds you of a movie you watched? Yeah. Well, sometimes those kind of things, making little videos like that or making up songs like that can help you to remember things. All right. So back to the energy. Remember that the energy that's in the wind came from the sun. Isn't that funny to think of that? The wind came from the sun. So the sun's rays are going to shine down and they warm the surface of the earth, but they don't warm every place on earth equally. Some places get really hot and other places stay pretty cool. So when an area is warm, when the land is being warmed, some of that warm air rises up. Well, when it rises up, it leaves a space behind and something has to fill that space. So air from other cooler places whooshes in to fill that area. That's wind. It's the whooshing of air as it goes in to fill the space where warm air rose and moved out of its way. So the air that rises up eventually cools and then sinks to the surface again. Now this should remind you of something. Remember we were learning about the mantle? We learned about liquid moving up, warmer liquids raise up, and then cooler liquids go in to fill their space. Right? You guys remember learning about that. Anybody remember what that was called? That circular movement of the magma? It's called a convection current. Same thing happens with the wind. Warm air rises up, cool air rushes in to take its place. The warm air now cools down and it settles back down. And we get these same swirling motions of air, these same convection currents. So the energy that's in the wind comes from the sun. All right, we're going to play a little game now. I told you guys to bring paper and pencil. Didn't I? I think, yeah. All right, so draw this chart on your paper. Just three, you're just going to have 3 columns. One, you're going to label igneous. One, you're going to label sedimentary. One, you're going to label metamorphic. We'll put metamorphic in the middle. Igneous, metamorphic, sedimentary. I'll send it to you, Isaac. I'm not going to put it in a lesson, but I'll just send it. I'll send the link. Okay. All right. So here's what we're going to do. Once you've got that drawn like that, I'm going to read a scenario and you're going to tell me which type of rock I'm talking about. Now, at the end of the game, whoever has the most correct boxes is going to get 5 extra credit points. And if we have a tie, we're going to play rock, paper, scissors. Get it? Rock, paper, scissors to break the tie. All right. So we're going to try the first one and I'll show you what I mean. All right. So this is just a practice one. This one isn't going to count. All right. How do you change? You lie deep below the surface of the earth where there is extreme heat and pressure. A fault, which is a crack in the earth's crust, nearby fills with magma, increasing the temperature around you. This causes your minerals to change. What rock do you change into? Okay, so you change. So what's the correct answer? You're going to put a check mark in the column that you think is correct. So let's say that you think the igneous is correct. You're going to put your check mark right there. All right. The correct answer to this one is not igneous. It's metamorphic. So if you got it right, if you did, because igneous would have to melt, and we don't have melting happening here. We just have increased temperatures causing change, not melting. So if you put a check in igneous, you got it wrong. So don't circle it. If you put a check in metamorphic, circle it. At the end of the game, whoever has the most correct circles is going to get 5 extra credit points. Okay, everybody understand what we're doing now? All right, here we go. This is a real one now. How do you change? You lie deep in the Earth's crust. You slowly melt from the heat of the Earth's mantle. As Earth's plates shift, you get pushed up toward the surface and cool and harden in the process. What rock do you change into? All right, put a check in the column you think is correct. Now I'll tell you the correct answer. The correct answer is igneous. So if you got it right, circle your check mark. If you didn't, don't circle your check mark. All right, here's the next one. A glacier slowly flows over you, crushing you and dragging you. As you get ground into tiny pieces, you become cemented to other rock particles. The glacier passes over and leaves behind clusters of these cemented particles. What rock do you change into? Put a check in the column you think is correct. The correct answer is sedimentary. If you got sedimentary, circle your check mark. All right, Arhan.
Karen?
Yes.
So, like, how are we supposed? So I drew the columns, and let me unblur my background 1 second. So I drew the columns, and I'm trying to check them. But how do you like check if we got them right?
I'm gonna trust you.
Okay, nice.
All right. I always assume people are trustworthy unless they prove that they're not. So I'm going to assume that you guys are trustworthy. All right, here's your next one. How do you change? You lie near the bottom of the crust, 10 miles below the surface. With the intense pressure of the rocks above you and the heat from below, you are transformed into another type of rock. What rock do you change into? Put a check in the column that you think is correct. The correct answer is metamorphic. If you got it right, circle your check mark. All right, it's not going to be igneous because it didn't melt. In order to be igneous, it has to be melting. All right, here is another one. How do you change? You slowly crumble as rain, ice, and wind erode you. The rain washes you down to the bottom of a river. You are glued to other deposits under the pressure of the river's water. When the river runs dry, the hot sunlight bakes you, making you hard. What rock do you change into? Put a check mark in the column. The correct answer is, what do you think?
Sedimentary.
Oh, sedimentary, yeah. So if you got it right, if you pick sedimentary, circle your check mark. You get buried under sediment on the ocean floor. You get forced underneath the North American continent toward the center of the earth. You slowly melt from the heat of the earth's mantle. You get forced up and harden in the cold water. What rock do you change into? What do you think?
Igneous.
Yeah, it is igneous. So if you put igneous, circle your check mark. The roots of trees grow into your cracks, breaking you out of your rock bed. You fall to a nearby stream. The stream breaks you down into smaller pieces, which get washed downstream. The stream dries up and your pieces become cemented to other bits of rock around you. What rock do you change into? Correct answer is sedimentary. If you put sedimentary, circle your check mark. You are part of a tectonic plate colliding with another plate. Your plate gets forced under the other, causing incredible friction. The friction produces heat and pressure, transforming your minerals. What rock do you change into? That would be metamorphic. Enough heat and pressure to change you, to deform you, but not enough to melt you. So that's metamorphic. Circle it if you picked metamorphic. An earthquake jolts you from your resting place and you tumble downhill, breaking into smaller pieces. A flood washes these pieces away to the ocean. The weight of the ocean's water cements you to other bits of rock on the ocean's floor. What do you change into? Go ahead, Arhan.
Why rocks in one category?
I'm sorry, I can't hear you. You're too far from your speaker.
There's 4 in one of the categories.
Okay, don't tell. You don't want to tell. All right, this is sedimentary. This is a sedimentary rock. The layers get cemented together. All right. Boom. A volcano close by has just erupted. That should give you a hint. Lava flowing from the volcano swallows you, melting you instantly. As part of the stream of molten rock, you eventually cool and harden. What rock do you change into? You melted, so you are igneous rock. Put a circle around it. So this is an example of how an igneous rock can be formed on the surface of the earth. It doesn't have to be deep down in the mantle in order to melt. The lava can melt rocks that are right on the surface. All right, probably, Henry, we'll have to see. All right, you are a stone deep under the ocean's floor. A new fault in the oceanic plate allows magma to erupt to the surface near you. The intense pressure and heat from the eruption causes you to change as your minerals recrystallize. What rock do you change into? If you got metamorphic, circle your check mark. That is metamorphic. All right, you lie on the ocean floor and are buried deeper and deeper under sediment. As you sink lower in the Earth's crust, the heat and pressure increases. Eventually, this heat and pressure is great enough to change your minerals. What rock do you change into? Metamorphic. Metamorphic. You are lying in the middle of a field. Suddenly, a flaming meteorite from space smashes into you. You are melted from the impact with the hot space rock and flung into the air where you cool and harden. What rock do you change into? That would be igneous. Igneous is formed from melting rocks. All right, that's it. Now count your circled check marks. Did anybody get all of them correct?
Me.
Oh, look at that. All right, so let me write this down. I'm impressed. So Valet, Henry, hold still, Arhan, Jasmine, Isaac, Kaylin, Meredith. All right, did I miss anybody? Put your hand down if I said your name. Valet, Henry, Arhan, Jasmine, Isaac, Kaylin, and Meredith. Anybody else? Get them all correct. All right, you guys know how to play rock, paper, scissors? All right, you got to hold your hand up so we can see it. Now, this is going to be tough because, you know, they all kind of beat each other.
Wait, how about what if we send a private message to you when you say go?
I can't hear you, Isaac.
The only problem, you hear me now?
Yeah.
It might glitch and they might be able to see what you do. So
yeah, that's true. So you have a better suggestion?
We could both send we send a private message to you.
Saying what?
You would send like a private message to you, like which one you want.
All right, here's what I'm gonna do. I see what you're saying. All right, we're gonna do something different. So because I want to have time to play the to do a Kahoot too. We do have one of those. So those of you who got them all right, you're gonna get the 5 extra credit points. Everybody else in class is gonna get 2 extra credit points because you guys participated too, right? So everybody's gonna get a little bit. So let me make sure I have everybody now. So Maisie, JR, Drake, Helena, Aisha, Cam, and Leah. All right, is there anyone whose name I did not say? This will be 14. 1, 2, 3. Yeah, I got everybody. All right. All right. So let's do a Kahoot now. All right. We do have a Kahoot to do. This is a Kahoot about the rock cycle. So it's not very long. Let me drag it in. Here we go. Go to www.kahoot.it. Kahoot. Do any of you guys use the QR scanner to get there? If you have a QR scanner on your phone or your tablet, you just have to point it at that and you don't even have to put in a game pin. It just automatically goes there. The code is 929296. 929296. This is a video of the Earth at night. All the lights showing. All right. 929296. All right, is everybody in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think we're missing a couple of people.
I can't see the whole thing. Oh, wait, here we go. Never mind.
Okay. All right, I'm gonna count down from 5 and then start the game. 4, 3, 2, 1. Here we go. Rock cycle and rock types.
Miss Joseph, can you put the code in the chat?
Yes, I sure can.
Thank you.
You go. Oh, I actually sent that direct. Hold on. There. Whoop. 929296. Okay. 929296. That's it, right? Yeah. Yeah, that's it. Okay. What is not a rock type? Marble, right? The 3 rock types are metamorphic, igneous, and sedimentary. All right. The bomb got there first. Arhan and Kaylin. Close score. All right. Now pick more than one. Which is true? Pick all the true ones. Ooh, good job. Yeah, they can all become all other kinds of rock, and they can even become themselves. So all 3 kinds can become metamorphic. Excellent. Well done, everybody.
Shoot, I forgot to click submit until the last second.
Yeah, you have to do that. All right, another multi-select. The energy that drives the rock cycle comes from where? The energy that drives the rock cycle. It comes from the sun and heat from the inside of the earth. Now, the sun provides energy for the wind, but the energy doesn't come from the wind. The energy comes from the sun. All right. So V is in the lead, Jasmine and JR, second and third. This rock forms when magma hardens beneath Earth's surface. Yep, igneous, not metamorphic. We've got this melted magma that hardens. That is igneous. Whenever there's melting, it's igneous rock. Metamorphic does not involve melting. All right, JR moves into second place, followed by Kaylin. Sedimentary rocks form from what? Compaction and cementation. Isn't that a beautiful picture? Look at that. I'd love to walk through that. All right. Here we go. Kaylin moves into second place. Henry the 7th. Henry the 7th. All right. What is transportation of material by water, wind, or ice called? That is called erosion. Weathering is the breaking down. The transportation is called erosion. Weathering breaks down, erosion carries it away. All right, the bomb moves into second place. V holds the lead. Dissolved minerals forming in the tiny spaces between small particles of rock. That is cementation. Cementation is when those dissolved particles get between, they form like a cement in between those small rock particles. All right, no change. Question 8. Pick more than one. What is visible in this picture? Oh, good job. All but cementation. So let's look again. There's sediment. That's what we see right here. The sediment is being deposited right in this area, and we can certainly see erosion happening that is carrying the particles downhill. We don't see the cementation happening. It probably is happening, but we're not seeing it in that picture. All right. 3 more questions. What is a major process in the formation of sedimentary rock? Cementation is necessary for sedimentary rock. Otherwise, it would just stay sand. It would just stay sediment. Question 10. The oldest layers of sediment are found where? Top of the formation, middle of the formation, bottom of the formation. They're found at the bottom. The oldest layers form and newer ones are on top of that. All right, last question. Select one similarity in how metamorphic and sedimentary rocks form. That's a lot to read really quickly. I know I should have given more time on that one. They both form from pre-existing rocks. They don't both form from precipitate out of solution. They don't like, things dropping out of solution. That would be just sedimentary, not metamorphic. Sedimentary doesn't form from heat and pressure. That's metamorphic or igneous. They don't both form from cementation. That's just sedimentary. The only thing they share is that they both come from rocks that were there before. All right, let's see our podium now. 3rd place, Meredith. In 2nd place, Jasmine. And in 1st place, all right, V, well done. Excellent job. I love the confetti that comes at the end of this. All right, so one of the things that I really want you to carry away from these lessons about the rock cycle is how dynamic our Earth is, how it is constantly changing. It's constantly reshaping itself. Parts are being taken away, parts are being built back up. We have a very active ecosystem on our Earth and an active, area that the living things share, that we live on. So very well done. All right, anybody have any questions? Yeah, I know, Kaylin. Sorry about that. Yeah, that was fast. Got to read fast some of these. All right, if you don't have any questions, you are free to go. Have a great week, everybody, and I will see you next time. Thanks for coming. Bye.